So we will see how to perform a mode analysis in MSC Nastran. Firstly, this is the solid bar here. We will just try to mesh this solid bar. Just go to the model browser and do the mesh here. Once this is done, just go back here. Now we will firstly run a free modal analysis. Modal analysis is used to extract the mode shapes and natural frequencies. So these elements are in this component. As this is a solid, we need a property card. We will create a p-solid property as these are hexahedral solid elements. So I will just go here and change this to p-solid. And now I need a material. I will create one material here and give it the properties of steel. I can put 0.3 here and rho will be 7.99 tons per cubic millimeter. And once this is done, my material is created and I have created the property. Now in this component, I will just assign my property. The material will automatically be fetched here. Once it's done, we are all set to run a free modal analysis. We just need to create a few things such as a load collector here. First, we need to create the load collector. There is something called the EIGL card. Sorry, it will not be in the load collector. We need to create something called load step inputs. Here you will find real eigenvalue extraction, which is the EIGL card. Here you will find it in the new version. Then we just need to enter the number of modes, or we can enter the minimum and maximum. So we will put it here. Suppose we want frequencies up to 2000 Hz. So we will keep the other value at whatever the default value is. So we will leave it at a default. The other things are also default. And now we will create one load step, which is normal modes. In the method structure, we will call that load step input card. As there are no SPCs here, this is a free modal analysis. We will keep it as it is. For the other things, we will just create them here. For output, we will call for strain energy and stress. We will also call for displacement. The format will always be plus. We want an OP2 format. The disk format will again be set to plus. Now these things are done. We need to create one PAM card. And then here we can select the option to generate the OP2 file param post -1. So we have selected it here. The other one is the SOL card. The SOL card is also important, so let's try to run this. So here in SOL, we will just put normal mode. Then this is done and we can export it now. So let me just export this file and name it maybe free model. You will just open this 06 file. So if you see this now, we have 8 modes because we requested to extract the natural frequencies up to 2000 Hz. The first 6 modes are basically rigid body modes. They are very close to 0 and the other two are flexible modes. You can see this regarding the eigenvalue. If you take the square root of this eigenvalue, you will get this omega. And from omega you can calculate the natural frequency. From omega, if you divide it by 2 pi, you will get the frequency in cycles per second. So this is how the calculation works. Now we will just open this. In the OP2, we will open HyperView to open our OP2 file. So this is our OP2 file and we can select modal animation. And you will see that this is the first rigid body mode. As expected, there will be 6 rigid body modes. Then mode 7 will be one of the flexible modes here. It is a bending mode but with a different mode shape. Okay. Now this is the free modal analysis. What we can do is constrain one of the ends and then run this again. Then we will run this again. Now we will go here and create one load collector. I will just go to and constrain these nodes. Done. Create. So I have constrained the nodes from 1 to 6 to these nodes. So I have fixed this end and now I need to call this collector in my load step card. So in the SPC field, I will call that load collector. That's it. Now I will export that again. Let's check the frequencies. Now I have got 4 modes between 0 and 2000 Hz and there are no rigid body modes there. Let's open it. Okay, I will just maximize this and now I will go through the mode one by one. So this is my first mode, which is obvious. The second mode will also be similar but with a different mode shape. Like this. The third is this kind of mode and the fourth is again a similar mode. But with a different mode shape like this one. So yeah, this is how you can do a modal analysis in MSC Nastran. We have seen both the free modal analysis and the constrained modal analysis. By the way, the PDF file we used will be in the attachment. You can download them and play along with the model. Thank you. Have a great day.